Do you guys know if the others are coming today? And have you guys been doing the stuff online?
Yeah.
Do you know if like your group has been doing it?
Yeah, they've been doing that.
Okay. Well, I just mean like
Oh, okay.
the
No,
people,
I don't know.
like you're usually with Devin and Jesus.
Yeah, I don't know.
Alright. So I'll probably send out some more announcements that I am indeed back. And we are going to start. I am now starting recording of the lecture. So for them, if they've missed, you can let them know that I will be posting recordings rather than before it was just the slides because there were no pre-existing recordings. All right. The other thing is we are starting Pull Everywhere again. So you guys know the link. It's 975. And today we're covering variables in MATLAB. So we can just start with just defining simple variables. Right, like if we need integer in C++ or C, we would define it as an integer type. But for MATLAB, we kind of just give things names, kind of similar to Python, if you guys have used Python before. And then its variable type is just given by what are you assigning to it. Okay, so here we have A is being assigned 1, so A is going to become an integer. Whereas if you did A as 1.2, it would be a floating point. So it all depends on what you're assigning to the variable. Whereas C and C++, you need to kind of define what type they are before you assign any values to it. And those values need to match that type. So in some ways, this is more convenient, but also it can lead to some errors if you're not careful with what kind of variables you are using. And then all variables are created as matrices. But this is just a 1-by-1 matrix. So we can do a couple of examples with this. I have MATLAB open. Here it is. Right. We want to assign A, let's just call it 10, right? So A is 10. So the command window is prompting you and showing you that A is indeed assigned 10. And down here, we can also see that it's a matrix of size 1, 1, right? And the value in it is 10. And this workspace will show all of your variables. You can sort them by name, sort them by value, or size, or what kind of value it is. And if you don't want to scroll through this, and you know the name of the variable, you can just type it and enter. It'll tell you what the value is. So these are variables. Any question? Yes. A matrix is just a data type. Like it has rows and columns. Right? So usually they're written like this. Like maybe it's a 2 by 2, 2, 2, 3, 6. Right? So 2 rows, 2 columns. So in this case, A is just a 1-by-1 matrix. Any other question?
But every variable is a matrix, right?
Yes.
So that's even more data or even more memory?
Not really, no. Because even in like C or C++, it's just a double that takes up the amount of space a double takes up. It doesn't take up more memory to say that it's a matrix. So you have, again, here the plane that shows you what these variables are. And you can also have these other types of variables, like we can assign Boolean variables. B is false. So let's do that. So B is false. So it makes it logical 0. If B were to be assigned true, it's just logical 1. And you can see the class type becomes logical. It's either going to be 0 or 1. Are we good with those? And here are some more matrices. So this is a 1 by 3 matrix, 1 row, 3 columns. So we can make any matrix size by just using those square brackets. So we wanted comma, and comma separate columns, semicolons separate the rows. So first column has 1, second column has 2, third column has 3. This is going to create a matrix where A is 1 by 3, 1 row, 3 columns, and the values are 1, 2, 3. And one thing to note is MATLAB does not start with 0 index. If I do A at 1, like this, A at 1, like this, I get 1. It does not start at 0. And then here is a 2 by 3. So 1, 2, 3 for the first row, and then 4, 5, 6 for the second row.
That's in one column.
Yes. Otherwise, it'll tell you it's mismatch state. So what were we going ahead here? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And one other thing is if you don't want it to print out anything to the console, if you end your line with a semicolon, it won't print out anything. But it still saved B over here. See? I can check B, and it is 2 by 3, 1, 2, 3, and then 4, 5, 6. So if I wanted 5 out of this, what would be my row number?
2,
And what's the column?
2.
Also 2. And that is the location of number 5. And of course, we can go here. So here's C, 1, 2, 3, 4, 5, 6, 7, 7. So that's how you're going to construct different size matrices. Any question on it? Okay. Here are some more examples. We have D is 1, 2, 3. So it's a 3 by 1 matrix. So it's more of a column vector. And this operator right here, what would you call that operator? Yeah, it's transpose, but what? Single quotation? Yes, right. Single quotation is the transpose. So if we make E 1, 2, 3, this is row-wise vector, right? Has 1 row, 3 columns, and then we do E is E transpose, then we get a column-wise vector. And transpose is just swapping all of the rows with all of the columns. So let's look at another example of doing the transpose, just so that we can ensure that it's doing. So let's go back to 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to create a what size matrix?
3 by 3.
And then in the first row is, right. And we can double check that. So it is indeed 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we do B, it's going to be B transpose. And I'll put the semicolon so it doesn't show us what it looks like. Now what's the first row?
1, 4, 7.
Because what's the first column? What's the first column? So the first row is 1, 4, 7.
Oh,
What's the first column?
1, 2, 3.
1, 2, 3. Okay. Because it just swaps rows and columns. So 1, 2, 3 became 1, 2, 3, 4, 5, 6, 4, 5, 6, 9, 7, 8, 9. Okay. And here are some quick ways to make some different matrices. So if you want 1 through 10, you can just say A is 1, colon, 10, and it creates the step size of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a lot faster than typing out A is 1, 2, 3, 4, 5, 6. And then if you have a different step size, you can put the step size in the middle. So this is going to be 0 through 10, but skip every other one. Okay. So it's going to be 0, 2, 4, 6, 8. And then here we have 1 through 5, where our step size is 0.5. So 1, 1.5, 2. So just to verify that these things work, what's something that you want to track? So A is what? 5 through?
5, a 2-step increment.
There you go. Okay. So 5, 7, 9, 11, 13. That makes sense. And you can also have strings in MATLAB. Have you guys started working on the first lab from last week? So you already saw an example of a string. So that is due this Friday. And like we did last semester, I'm going to set Fridays as the time in class to work on all of the labs. So last week, Friday would have been that time, but everything was online. Yes.
And so for this lab, it says submit the code, you just.
Yeah, give me the M file. Yeah, the M file. The M file. And I just got Gradescope up, so you can submit that. And just like last semester, we work on the lab on Friday, and it's due before class the next Friday because that's when you're starting to work on the next lab. So it should be done before then. All right, so let's try it. So C is and here we have a char vector 1 by 11, right? Because I can do C as, let's say, what's at 5, the characters O, right? Because again, everything in MATLAB is a matrix. And then here are some other very useful things. So like if you need an all zero matrix, you do A is zeros. 3. Any guesses on what this will make? Yes, a 3 by 3. Not just a 1 by 3 of zeros or a 3 by 1 of zeros, but a 3 by 3 of zeros. So if I wanted a 1 by 3 of zeros, what do you think I can do? Okay. So that is our zeros command. You can give it any shape. If you only specify one shape, it makes a square. Same thing with ones. So if I do b ones, this is going to create 5 by 5. So I want to 1 by 5. Do 1 by 5. And we also have the random command. So let's do something a little smaller so that we can see it. C is and 2. So this is 10 by 2, random numbers between 0 and 1. And if I needed a random number between a different range, what can I do? Like say I needed a random number between range 0 and 5. How can I use this rand function to achieve this?
Ten, comma, 2, comma, 5.
It's simpler than that. So the rand function is going to create the matrix of the size that you specify, right? So 10, 2, 1, 5, 5, 5. It's just specifying the size. But the range of the random number is always 0 through 1. So if I wanted it to be 0 through 5, what can I do to the range?
Five times the rand function?
Yeah, just multiply the random function by 5. So here, 1, right? So 1, 1. Range. I multiply it by 5. Now it's the number between 0 and 5. So you're going to use the same base random function, but you can modify it by manipulating the range. So I, 20. Does anyone know what I is going to be? Any guesses? Anyone taken multivariable calculus yet? So this is something. So let's do I, 5. It's just the identity matrix. So on row 1, column 1, there's a 1. Row 2, column 2, there's a 1. Row 3, column 3, there's a 1. Row 4, column 4, there's a 1. Row 5, column 5, there's a 1. Everywhere else is a 0. This is called the identity matrix because if you multiply this by another matrix, you get that matrix back. So let's do rand 5 by 5. Use rand 5 by 5. Right. So it gives me this 5 by 5 matrix. Now I do E times D. I just get E back. That's why it's called the identity. And then here, this is just you can print commands. Let's see. We want a decimal and an end line, and then the number 9. Right. So that is our basic variables. But we have more. So we can do some strings. And we can also search through strings with these commands. A was on visionary and geometry. Vision and geometry. Vision and geometry. Right. So let's do string 9. A, and we're looking for, does it contain geometry? And it is at character 12. Okay, so we can verify this, right? So let's do A, 12 and onward. Geometry. And this, again, was just making a matrix that started at 12, and it went until the end of A. Right? So it's using that same concept that we learned up here, right, with the indexing. So like if I wanted A from 12 to 15, I would just get that little segment. You can also do string compare. So string compare A, and we're going to computer vision. These things are the same or not the same? Okay. So we get our answer is false. String cat. So B is str cat. What do we think string cat is going to do? Two, three, 5. So we have vision and geometry, 1, 2, 3, 4, 5. And then here's just, let's do C, A, comma, 1, 2, 3, 4, 5. And now we have C right here. It's another way of cat. Because this was already just a 1 row vector, and we put a comma, and then we added more to that row. So we're accomplishing the same thing. That's with a different command. Okay. We also have these different operators, so we can check if things are equal. So let's see. Is 5 equal to 4? No, right? 4 equals 4? Yes. They're not equal. Yes, this is. We have comparisons for smaller, greater, smaller than or equal to, greater than or equal to, and then we have also the Boolean logic operators. So true and true is true, right? Or equals core. Or going to be also resulting in true. So those are creating variables, the different types of variables, some simple functions that you can call to make more complex variables, like the indexing, right? And then also some comparison operators. So just like starting with any other language, knowing these things, it's a little bit different than other languages, but if you have that prior experience, it applies also to these things. Just the syntax is a little different, right? Like when I was trying to access A and I forgot that it's not square bracket, it's just parentheses, right? So I think that is all for today. You guys do have a reading for chapter 4 for Wednesday. And we have around 20 minutes left. So I do want to just spend that time to kind of again quickly go over how we're going to run the class, because we didn't have that first day, but also to kind of query how far you guys did get with the first week. So for the first week, were we able to install MATLAB and simulate? Yeah, I see nodding heads, but can I have raised hands? So on the browser, I haven't used Simulink. I believe it works, but I'm not sure. We will find out. But it shouldn't take up too much space if you only install MATLAB and Simulink. So if you can, I would do, because that also enables you to just work on stuff without internet, if you end up in that situation somehow. And then if you've installed MATLAB, you started lab 1, finished lab 1. Okay, and then I have finally gotten Gradescope working. So Gradescope, the submission is open for lab 1. So just like before, this first report is going to be very short, okay? But just like we did for 100, the same report guidelines, and then the same, just also upload your code to the other submission, and only one submission for each group, right? And the only thing that is different from 100 and this course is we now have the Zybooks, right? And before, not every single class, but about each class, you'll do the reading before class, and then what we talk about in class will be related to the reading. Okay? And just like before, Monday, Wednesday is like contents, Friday is time to work on the lab. And depending on the lab, I might give you Wednesday and Friday. Any question? All right, before I let you guys go then, just want to make sure that everyone knows that the code is 970.